today's lecture, we will focus on enabling technologies that led to emergence of cloud computing. So what we see here is convergence of many technology fields, uh, ranging from hardware to internet technologies, system management, distributed computing, which led to growth and maturing of cloud computing. So system management has autonomic computing and data center automation. Distributed computing has utility and grid computing. Hardware has hardware virtualization and multi-core processors. Internet technologies have SOA, which stands for Service-Oriented Architecture, Web 2.0, Web Services, and Mashup. Our focus will be today to explore the internet technologies which led to the emergence of cloud computing. In the previous lecture, we have seen some foundation technologies or trends in computing which led to evolution of cloud computing. We saw that definition of cloud computing overlaps with utility computing, grid computing, and distributed computing in general. So these were the foundation technologies for cloud computing, and today we'll focus on enabling technologies. Foundation technologies are those technologies on which a new technology depends. Whereas enabling technologies are those technologies which help a particular technology to emerge or come forward. Before getting into enabling technologies, let us try to understand, let us take a case study and try to understand how an application for online parking ticket can be created. Now, if a user wants to create an application to pay the parking ticket online, then the user would need to create sub components where there will be requirement for street map, there will be a requirement to take care of the payments, there will be requirement for user login and authentication. Now, the user who is trying to make this application can either code all these subsystems and prepare a well-bounded piece of software. On the other hand, for maps, there is already a service, Google Maps, which is available. For payment, there are existing payment gateways like Paytm, PayPal, and many others. For user authentication, Facebook or Gmail can be used. So instead of coding every subcomponent, what can be done is that these existing services which are available through web, they can be utilized, put together, and to deliver a desired functionality. So the building block service might be pre-existing component that are reused and can also be updated or replaced without affecting the functionality or integrating of the other independent service. So instead of building every functionality, every service, payment service, map service, login service on its own, what can be done is that the user just takes a service from Google Map, chains it to the payment gateway, chains it to the authentication available from Facebook or Gmail, and deliver the desired functionality or create a new service. So in this, these building block services, that is these Google Map or a payment gateway or Gmail, they are, if any one of these is updated, it does not affect the functionality of others. So in consumer web, information and services may be programmatically aggregated, acting as building block of complex composition called service mashup. So mashup is like some kind of combination. So here what has been done is, instead of writing the code, many services have been taken and they have combined to come up with a new service. So this is much more convenient and much more scalable way of doing the things. Now let us look at a definition of service before we go ahead and look at the enabling technologies. So what is a service? It's a software component that provides a set of coherent and related functionalities that can be reused and integrated into a bigger and more complex application. So for example, Paytm is a service. So that can be incorporated, or it can be reused by many other services for payments. Next, services are most often built in a way that it is independent of the context in which they are being used. So this is an important point. Any service which is being built should not be tightly coupled to a particular platform or technology. Right? It should be independent of the context in which they are being used. So let us see what a service is supposed to be. A service is supposed to be loosely coupled. So the coupling indicates the degree of dependency any two systems or services have on each other. So loosely coupled allows the services to serve different scenarios more easily. So what will happen if a service is tightly coupled? It would need to know how the partner application behaves, right? They would need to know every detail of the other application they want to communicate with. And on the other hand, loose coupling of application provides a level of flexibility and interoperability. Second, a service should be reusable. It can be reused in many services. So it should be like a block which can be picked up and placed into anywhere to come up with a larger application or a bigger service. It should be programming language independent. If a service is independent or is programming language independent, then the accessibility of that particular service increases. And of course, it should be location independent. It does not matter from where the service is being offered. So let us see what service-oriented architecture is. Basically, in service-oriented architecture, everything is dependent on service. Service is what is provided by the service provider and consumed by the user. So it is an architectural style supporting service orientation. Service orientation is a way of thinking in terms of service and service-based development and outcome of service. So in service-oriented architecture, what is offered is a service, and using these services, by aggregating these services, new services can be built. So service-oriented approach adopts the concept of service as the main building block of applications and system development. As we saw in case study, if many services, the existing services were taken and were aggregated, it built an application which was much more scalable, it was faster, it was flexible, and it was interoperable. So SOA also defines a way to make system components reusable via service interface. This is very important. It is the service which is being offered should be reusable. Next, service resources are packaged as well-defined and self-contained module to provide service business functionalities that are independent of the state or context of the other service. So in this, the service resources, they should be well defined. Well defined means it should be very well defined that what should be the input of this service and what will be the output of the service. And they should be self-contained modules. They should be independent modules that should provide a certain standard, that means a certain explicit business functionalities, and they should be independent of other services. So let us look at a more precise definition. SOA is a logical way of designing a software system to provide service to either end user application or to other services distributed in a network via published and discoverable interface. Now, what is important here, that the service can be provided to either end user application or to other services also. So services can also invoke other services for certain tasks to be done. So this architectural approach is particularly applicable when multiple applications running on varied technologies and platforms need to communicate with each other. So what is the goal of SOA? It is to enable general purpose interoperability among existing technologies and extensibility for future purpose and architectures. Next, let us look at what are web services. So web services are prominent technologies for implementing SOA systems and applications. So a web service is a self-describing, self-contained software module available via a network such as internet, which completes tasks, solves problems, or conducts transactions on behalf of user or application. Now let us look at this. It is self-describing. So what do we understand by this term, that it is self-describing? It means that it knows what functions it can perform and what inputs it requires to produce its output. It can also describe its non-functional properties like cost of invoking the service and geographical area that web service covers, etc. It can describe this to its potential user and to other web services. So a web service is self-describing. It knows, it will describe everything. What is the what function will it perform, what are the inputs required, what will be the output. It will also describe what will be the cost of this, and etc. Then it is self-contained. That means it is modular, and it is available over a network, which is usually internet, and it completes a task, or it can solve a problem, conduct a transaction. What is important is it can do it on behalf of a user or other web services. So a web service can invoke another web service. So this is a very important point here. So web services are loosely coupled software modules. We have understood what loosely coupled means. Defined in a neutral manner that is independent of the underlying platform, the operating system, and the programming language the service is implemented in. So these are what a service should be, and a web service is loosely coupled. It is independent of the underlying platform, operating system, and programming language in which it is implemented. Then it is self-contained software module that performs a single task. It will perform a specific task which it is mentioned. So output is defined, and what inputs are required for that are also very well defined in a web service. The module describes its own interface characteristics in such a way that other software modules can determine what it does, how to invoke its functionalities, and what results to expect in. So it has a very clear interface characteristics. Then web services are not targeted at human users. Rather, they are called by and exchange data with other software modules and applications. So it is basically for a machine to machine or a application to application interaction. It is described in terms of a standard description language, and that is called as Web Service Description Language, WSDL. They are distributed over internet and make use of existing transport internet protocol like HTTP. So what web services do is to they glue together applications which are running on different messaging product platforms. They enable information from one application to be made available to other applications. They also enable internal applications to be made available over internet. And for web service, a rich software stack has been specified and standardized, because of which it has become a very popular way of implementing SOA. So now let us look at some examples of a web service, that is what a web service can be. First, a self-contained business task. For example, fund withdrawal or a fund deposit service is a web service. Next, full-fledged business processes. For example, automated purchasing of office supplies. So if you look at this, for purchasing the supply needs to be monitored, the inventory needs to be checked, that what is lacking and what is not, and accordingly order has to be prepared, and that has to be placed. So this will require to invoke many other web services. So it can be done. A full-fledged business process can also be called as a web service, because web service can be collection of many other existing web services also. So a web service can also be an application, for example, life insurance application or demand forecast and stock replenishment. A web service can also be a service, that is enable resource, for example, to enable resources such as to access backend database containing patient medical record. So web services vary in function from simple requests, for example, pricing inquiry, weather report, to complete business applications, for example, packaged tracking system, that access and combine information from multiple sources. So now let us look at what is Web 2.0. So web is the primary interface through which cloud computing delivers its services. It encompasses a set of technologies and services that facilitate interactive information sharing, collaboration, user-centered design, and application composition. So if you look at the advancements, what has happened in the web, if you look at a web page, a old web page, it was not at all interactive. If you look at the web page, it was all it had was a lot of information, could not take any input from the user. If user wanted to, if there was something where the user had to be deflected, all it used was hyperlinks and hyperlinks. Right. On the contrary, if you look at the your web page today and how it looks, it is very interactive to the user. We can add information, we can build content. For example, if you look at Wikipedia, so users are not just reading the data, they can edit the data. So they have become content providers. So this evolution has basically transformed the web into a rich platform for application development and is known as Web 2.0. So what does it do? It brings interactivity and flexibility into web pages. These capabilities are obtained by integrating a collection of standard and technologies such as XML and asynchronous JavaScript and XML AJAX, web services, and others. We'll look at what AJAX is in later lectures. These technologies allow us to build applications leveraging the contribution of the users who have now become providers of the content. So examples of Web 2.0 applications are Google Documents, Google Map, Facebook, Twitter, YouTube, and Wikipedia. So in today's lecture, we understood that what is a service, what is a service-oriented architecture, which is nothing but thinking in terms, it's an architectural style which thinks in terms of service. Then we saw that web service is a technology for implementing service-oriented architecture. So basically, it is an idea where a fully functional web application comes into practice just by gluing pieces of services, existing services with few lines of code. So every service required need not be written. What can be done is existing services can be taken and they can be joined together to come up with a new service. Many service providers such as Amazon, Facebook, Google, they all make their service APIs publicly accessible using standard protocols. This concept of gluing services together initially focused only on enterprise web, but then because of the advent of Web 2.0, it gained immense popularity with the users as well. These are the references. Thank you.